In this lesson, I'm going to show you how to convert between radical form and exponential form. Notice that the radical form includes a root sign and the exponential form includes an exponent. And in this diagram, you can see that the index, which is the little m, is going to become the denominator in the exponent, and the exponent in the original radical form will become the numerator in our exponential form. In the bottom example, we have our 6x, which is under the square root sign, and that will be the base of our exponent in exponential form. The little 3 in the front of the root x will now become the denominator, and the 4 exponent will become the numerator in exponential form. It's important that the 6x is in a bracket because we are raising the entire term 6x to the exponent of 4 over 3. If you don't have the brackets, it looks like just the x is being raised to the exponent of 4 over 3. But we want the whole thing, so make sure you include a bracket. Let's do some examples that are on the following page. Evaluate each of the following without a calculator. So we have 49 to the exponent of a half. So to write that in radical form, we would make a root sign, 49, and write a little 2 in the front. Usually, when we take the square root of a number, we don't bother writing that little 2 in the front, but we know it's there. It's standard. So if there's nothing in the front, then we assume it's a 2. We are taking the square root of 49, which means we're looking for a number that we multiply by itself, so some kind of a number times by itself since we have a 2, and that answer has to be 49, which would be 7, right? 7 times 7 is 49. Okay, let's do the same thing. We have a negative in the front this time. It's root 64 with a little 2 and then a minus in the front. So we're looking for a number multiplies by itself that is going to give us negative root 64. Root 64 is, square root of 64 is 8. Whoops, lost my marker there, is 8. And then we can just add that negative that we had originally to the front there. All right, 125 to the 1/3 is cube root of 125. So you're looking for a number that you multiply. So a number times a number times a number has to equal 125. Okay, and that number is going to be 5, because 5 times 5 is 25, and 25 times 5 is 125. So the cube root of 125 would be 5. Okay, question D. We are taking the square root of 49 over 81. That means we're taking the square root of 49 and we're taking the square root of 81, which is 7 over 9. Question E. 40 divided by 135 and then raised to the exponent of 1/3. What I would do here first is check to see if you can reduce that. Can we divide 40 and 135 by a common number? They are both divisible by 5. So 40 divided by 5 is 8, and 135 divided by 5 is 27. And now I can take the cube root of that. Right, cube root of 8 is 2, and cube root of 27 is 3. So the answer is 2/3. 64 to the negative 1/3. Remember your exponent rules. To change that negative to a positive, we're going to change 64 to 1 over 64, right? Bring that 64 to the bottom, and then that will give us a positive exponent. Now you can take the cube root of 1 over 64. So what number can you multiply by itself 3 times to give you 64? that number would be 4. All right, 4 times 4 is 16, and 16 times 4 is 64. All right, question G. I'm only going to do number 1. I'm not going to do number 2 and 3. Maybe I'll start you off on 2A in a minute, and then you can do the rest on your own. But back to G, negative exponent again. Let's flip what we have inside the bracket here, which will change our exponent to a positive exponent. That gives us 16 over 81 to the exponent of 1/4. So we'll make a big root sign, 16 over 81, and put a little tiny 4 in the front. Okay, what number can you multiply by itself 4 times to give you 16? That will be 2. And what number can you multiply by itself 4 times to give you 81? That will be 3. So it's 2/3. Question H. All right, so now we've got a different number other than a 1 that's on top of our fraction there. So our numerator is a 2. What we're going to do here is we're going to write 27 over 8 and take care of the 3 first. So let's make our root sign, put a little 3 at the front, and then we're going to square the entire thing, okay, afterwards. So let's take the cube root of 27 over 8. Number that multiplies by itself 3 times to give you 27 would be 3. 3 times 3 is 9, times 3 is 27. And then cube root of 8 is 2. So we have 3 over 2, and now we have to square that. 3 over 2 times 3 over 2 is 9 over 4. Question I, negative exponent again, so let's flip what we have inside the bracket, 32 over 3,125, and change our exponent to a positive exponent, 3 over 5. And now we are going to write it as a radical. 32 over 3,125. My denominator, 5, is what gets written in the front. And then put that in a bracket, and your numerator is on the outside. So we're going to cube our answer after we take care of the root sign. So 32, and we have a 5. So what number do you multiply by itself 5 times to give you 32? That would be 2. And then 3125, it's going to give me 5. If I multiply 5 by itself 5 times, I get 3,125. So we have 2/5, and we need to cube that. 2 cubed is 8, and 5 cubed is 125. All right, almost finished. Couple more. J, now we have our question written in radical form. So another way of writing this, if you wanted to write it in exponential form, you could say this is 1024 to the 1/5. There's no need for that, but I just wanted to show you how to write it in the other form. You're looking for a number here that you multiply by itself 5 times to give you 1024, and that number is 4. Right? Because 4 times 4 times 4 times 4 times 4 equals 1024. And the last one, we have cube root of negative 8. Okay, so what that means is what number do we multiply by itself 3 times to give us negative 8? That's what that question is saying, right? And that number would be negative 2. Because negative 2 times negative 2 is 4, and 4 times negative 2 will give us negative 8. So that is the answer. All right, I'm going to start you out with number 2. I'll just do the first example, just to kind of show you what kind of techniques you can use for these below questions. It says evaluate each of the following without the use of a calculator. So try your best without not using a calculator. So right off the bat, I see 7 to the exponent of 0. That will give me 1, so I can start with that. And then notice that you've got 3 terms that are multiplied at the top, and you've got 2 terms that are multiplied at the bottom. We can use exponent rules here as long as the bases are the same. So these terms here both have the same base of negative 2. So let's take care of that one first. So negative 2 is my base. I'm dividing the 2 terms, which means I'm going to subtract the exponents. 3 minus 2 is 1. And then I look at my second, let's use a different color here. Notice that we have a 3 to the 2 and 3 to the 6. So that's the same base. So we can multiply those two, or divide. So you're going to subtract the exponents. 2 minus 6 is negative 4. Okay, so we've simplified it. What can we do next? Okay, so negative 2 to the 1 is just negative 2. So we know we have negative 2 multiplied by 3 to the negative 4. So that has a negative exponent. I'm going to bring that back to the bottom to give it a positive exponent. So 3 to the positive 4. So that gives us negative 2 over, and 3 to the 4 is just 3 times 3 times 3 times 3, which is 81. So negative 2 over 81. And I don't think you can go any further than that. You can't divide 81 by 2. So that's all you would do here. Maybe I'll start you off on B as well. 3 to the negative 1 is a third. All right, you bring it down the bottom and to change the exponent to a positive 1. And then 3 to the negative 2 is 1 over 3 squared. And then at the bottom you have 1/3, subtract, and then 1 over 3 squared. 3 squared is just 9. So you need to work with fractions here. So you've got a third plus a ninth at the top, and a third minus a ninth. Okay, I'm going to let you finish that. Also C and D and all the way, and then try number 3. Once you're finished those questions, please try the textbook questions on page 229 and 236. Some questions for you to practice. All right, have a good lesson.